Calc-Path Geometry, Lesson 5.1, Perpendicular and Angle Bisectors. There are two theorems that we're going to be looking at and working with in this section, as well as their converse theorems, so 4 theorems in total. Start with the perpendicular bisector theorem. We're going to pull up the formal definition from the book that you can write down. Perpendicular bisector says, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Then it is equidistant from the endpoints of the segment. What does that mean in terms of our picture? I'm going to do this on the left because some of you might still be copying that down. So what that means is I have a line segment, and somewhere, right down the middle of it actually, there is a perpendicular bisector. It is both at a 90-degree angle and it cuts it like that's the midpoint right there, because the perpendicular bisector cuts this into 2 equal pieces, or 2 congruent pieces. Any point on this line, whether it's this point or this point or this point or one way, way, way down here or one way, way, way up here, the distance from that point to this endpoint will be the same as the distance from that to the other endpoint. So what they're saying is that if you are given that it is a perpendicular bisector, that's what this picture is showing. We have been given a perpendicular bisector. The conclusion is that AX will be congruent to BX. We could prove this very easily, because if we have a perpendicular bisector, we've got right angles, so we could prove that they're congruent by right angle congruence theorem. We have AY and YB congruent, be it by definition of bisector. And we have this reflexive, so we have 2 congruent triangles by side angle side, and by CPCTC, all parts of the triangles, including AX and XB, will be congruent. So we could prove this theorem very easily using congruent triangles. Right now, though, we're focused on if we see a perpendicular bisector, then we need to know that any point on that line is equidistant to those 2 endpoints. Now the converse theorem says that if a point is equidistant from the endpoints of a segment, so in this case we actually know that XA and XB are congruent, then that point X must lie on the perpendicular bisector of the segment. So if a point is equidistant to the endpoints of a segment, then it is on the perpendicular bisector. Of the segment. I'll leave that up yet again. So here we were given that AX and BX are congruent. So point X, since it is equidistant to the endpoints of the segment, the conclusion is that XY is the perpendicular bisector. Or in other words, AY is equal to YB and XY is perpendicular to AB. So that we can conclude, since those distances are equal, that this is a perpendicular bisector, that these are right angles, this line is perpendicular to this line, and this segment is congruent to this segment. Again, we could prove this because we have this by reflexive. We could prove that these angles are congruent. We'd have to go through a series of steps to do that, but we would be able to do hypotenuse leg then to prove these triangles were congruent. 2 other theorems that we're going to look at and use in these problems that we're going to be solving, pretty basic. We have the angle bisector theorem, which says that if a point is on the angle bisector, point C is on the angle bisector PC, then it is equidistant to the two ends. Remember, the distance from a point to a line lies on the perpendicular path. So starting at point C, we do a perpendicular path to PA, a perpendicular path to PB. CA and CB will be congruent. So again, that theorem says if a point lies on the perpendicular bisector, or not the perpendicular bisector, the angle bisector, then it is equidistant from the sides of the angle, which the sides are called the rays. So here we have our nice little picture. PC is the angle bisector. I can tell that because I see the two congruent angles there. That's the congruent angle mark, that those two are equal, which means that the distance from here to here and the distance from here to here has to be exactly the same. CA and CB have to be equal. The converse of this theorem is just switching the hypothesis and conclusion. That's what a converse is. It says that if a point on the interior of the angle is equidistant to the sides, then it lies on the angle bisector, or the bisector of the angle. The ray that bisects it. So in this case, we have the reverse picture. They've told us that CA and CB are congruent, and point C is inside of angle APB. So since A and B are on the rays of the angle and C is equidistant to both, that means that angle APC has to be congruent to angle BPC. That PC must be the angle bisector. That's all the converse is telling us. So we're going to look at some quick application problems. This is not too tough, and then we'll review something from first semester in terms of writing equations of perpendicular bisectors. Applying perpendicular bisector and angle bisector theorems and their converses. In this particular picture, we are told the distance from AB is 38 and the distance from A to C is 38. Well, since A is equidistant to the endpoints using the converse of perpendicular bisector theorem, we know that the A is on the perpendicular bisector, which means that BD and DC both have to be the same. This means that BD has to equal 12. They asked for BC though. BC would be 12 plus 12, which is 24. Letter B, TU is what we're supposed to find. It looks like we have been given a perpendicular bisector. Since U is on the perpendicular bisector and T and V are the endpoints, TU and UV have to be congruent. So if I set them equal, I'm going to subtract 3x from both sides. I now have 9 equals 4x minus 17. I'm going to add 17 to both sides. I now have 26 equals 4x, and 4 will go into 26 not evenly, but 6.5 times. So 6.5 is my value for x. They didn't ask for x, they asked for TU. TU is 3 times x, so I'm going to multiply my 6.5 by 3, plus 9. So TU is 28.5. If I plug that in, 7 times 6.5 minus 17 also gives me 28.5, so I know I found the value of x correctly, and I have the correct answer for TU, 28.5. Letter C, again, we are given the perpendicular bisector. We are supposed to set these two expressions. That means that NM and NL have to be equal, because this point on the perpendicular bisector has to be equidistant to the endpoints. So I have x squared plus 2x equals 3x plus 6. This is a quadratic, so we're going to get it equal to 0. X squared, I'm going to subtract 3x. I'm going to subtract 6. This one is factorable, x minus 3 by x plus 2. 6 and 1 will not work because they won't add to 1 in the middle. This gives us x equals 3 or x equals negative 2. If I plug in negative 2, it would give me a side length of 0 for nm, so that's an extraneous solution. That means that I'm going to use the value of x equals 3. 9 plus 6 is 15 for mn. 3 squared is 9 plus 6 is 15 for nl, so I know I have the correct value. Angle bisector problems. Letter D. We are told that AC is the angle bisector. They don't say it in words, but they say it by showing us that those two angles are congruent. This means that the distance from C to B and the distance from C to D has to be equal. So that was easy. BC is 7.2. Letter E. This time they don't tell us that it's an angle bisector, but they tell us that point M, which is inside of angle JKL, is equidistant to both JL or both to J and to L. Point M is equidistant to J and L, which means that M has to be on the angle bisector. We're allowed to conclude using the converse of angle bisector theorem. In letter G, we use the angle bisector theorem. In letter E, we're using the converse of the angle bisector theorem. We're allowed to conclude that those angles are congruent. So that means that 3a plus 20 has to equal 2a plus 26. Subtract 2a from both sides, subtract 20 from both sides, we get a equals 6. But they didn't ask for the value of the variable, they asked for the measure of, actually they didn't ask for anything. So we might be good with the value of the variable. If they asked for this angle, I could plug it in. 3 times 6 is 18. 18 and 20 is 38 degrees for each one of those angles. So if they had asked for the whole thing, I could say that the entire angle, measure angle JKL, is 76 degrees. It didn't specify what it was asking for. I found it all. I will specify for sure in the practice and on the assessment whether you're finding the variable A or the measure of JKL or just the measure of one of them. You should remember these formulas from first semester. If you don't, you really need to commit them to memory. You will be expected to go into Algebra 2 and be able to build the equation of a line very quickly. The slope, remember, is rise over run. Subtract the y's over the difference of the x's. The subtraction of the y's gives you the rise. Subtraction of the x's gives you the run. Midpoint. So this is rise over run. Midpoint is the average of the two values. So you add the x's and divide by 2, add the y's and divide by 2. Point slope form of a linear equation is y minus y sub 1 equals the slope times x minus x sub 1. We could easily convert by distributing the slope and adding y sub 1 to the other side to get it into slope intercept form, y equals mx plus b. But these formulas we should know because we can use them to quickly build an equation. Now you've done this exact learning target before in the first semester, so I'm only going to do one. If you need, you can see me for help later with 2 more. Write the equation in point slope form for the perpendicular bisector given the 2 endpoints. So I have a line segment CD. And I don't want to write the equation of the line CD. I want to write the equation of the line that goes through CD at a right angle and bisects CD. So I need this point, which you all know, remember from before that that's the midpoint. We're going to use the midpoint, so we're going to have to calculate the midpoint. And then I also need a slope for my equation. If I know the slope of CD, I don't want to use the slope of CD. That would give me the equation of the line CD. I want to use the perpendicular slope. And so remember, to get the perpendicular slope, we do the opposite reciprocal. So I'm going to start with the midpoint. I have 6 plus 10 over 2 and negative 5 plus 1 over 2. This gives me 16 over 2, which is 8, negative 4 over 2, which is negative 2. There's my midpoint. So I have y minus negative 2 equals whatever my perpendicular slope is, we haven't found it yet, times x minus 8. This minus a negative becomes a plus. For my slope, the slope of CD is 1 minus negative 5 over 10 minus 6. You could do it in the reverse order as long as you're consistent on top and bottom. This would give us 6 over 4, which is 3 halves. If the slope of CD is 3 halves, that means our perpendicular slope is negative 2/3. So I just have to write y plus 2 equals negative 2/3 times x minus 8. Now my equation is of this perpendicular bisector to CD, and it is in point slope form. That's what they asked for, was point slope form. If they also wanted slope intercept form, I could distribute the negative 2/3 and subtract 2 from both sides, and I would have it in slope intercept form. For this section, we're in luck. We're only asked to put it in point slope form. If you'd like to pause and try letter B, I'll reveal the answer to that in just 1 second. Assuming my quick calculations are correct, I found the midpoint of PQ to be 3, negative 1, the slope of PQ to be 3 halves, which the perpendicular slope would be negative 2/3. I then built my equation doing y minus the quarter of the midpoint, y minus negative 1 is plus 1, x minus 3, and the perpendicular slope in front, negative 2/3. There's the equation of the perpendicular bisector to PQ in point slope form. This concludes the video notes for 5.1. On Monday, you will be working on problems using the perpendicular bisector theorem, the angle bisector theorem, and their converses to set up and solve problems like at the bottom of example 2, and writing equations of perpendicular bisectors. Have a great day.